The Leave Plan of Room experts has tracked down that utilizing our new 101 billion toy, it will be evidently forever before that attempt changes into a reality. On the distant chance that it goes as organized, the trip to Proxima B will anticipate close to 20 years. So, reasonably, it will be quite a while before we can anticipate assuming there is certain life on that planet. The deepest, established deals of whether we are truly alone in this universe drive forward. Through the James Webb Telescope, we have found some staggeringly humanesque things far away from Earth that lead us closer to the reaction. Our mission for life beyond us has been uncontrolled all through each human activity, so much so that we have incalculable media works and theories concerning this matter. Our wonder concerning our place and importance in the universe has been dependable. It is plagued within us to look dependably for a mate, notwithstanding the way that, similar to us, we may get closer to the answers we seek. But are they the responses we are searching for, or are they just disturbing? Join us as we take apart the most moderate disclosures in the space of frameworks and planets on the excursion to find something we probably will not be ready to see. Lights far away. Specialists have found what could be the most critical discovery in history. Back in 2021, when the James Webb Space Telescope was intended to launch, an astoundingly captivating speculative demand was raised about the capacities of our innovation. The question was whether, later on, our telescopes could identify fake light on another planet, for example Proxima B, the closest exoplanet to Earth. Proxima B, around 4.25 light-years away, was perceived to be perfectly locked with an enduring day side and night side, like our moon. A speculative innovative upgrade for Proxima B could move power and energy from the day side to the night side using photovoltaic cells that make power from starlight. Thus, in a paper with Manis Ving as one of the specialists, it was shown that a legendary combination of the day side by solar chargers could be related to future telescopes. Since the JWST was additionally evolved, it would permit us to expand our quest for fake lights on exoplanets like Proxima B. Now, the fact that the James Webb Space Telescope did precisely that in 2024, utilizing its higher care and more noteworthy level of limits, is weighty. The JWST could have found the lights we were looking for and perhaps flung us into another tremendous flood of human activity. Generally speaking, we ought to dive into the universe of planets and exoplanets to sort out how this was conceivable. James Webb's central goal investigates Proxima B and its secrets. From the beginning of composed history, people have thought about the opportunity of the universe, what we are, where we come from, and where we go. These are customary yet shockingly badly designed sails that humanity has attempted to answer. When we gained mindfulness in the hour of fabulous mechanical improvement, one puzzles over whether we are any closer to observing these inquiries. If you somehow manage to ask a rationalist, he could say we are right now at level 0 of understanding ourselves in the universe. However, ask a space master the same question, and watch him take full advantage of his energy as he races to tell you the latest revelation people have made about the universe using their advanced tools. These instruments, yet not given a ton of thought by the general population, are directly an impression of human development itself. We presently have the world speedily open, and it's time we push forward and get the universe readily available. One such strategy for doing so has been determined by investigators and space specialists. Through the development we tackle, a specific creation of that advancement is now proficient in the new revelation of what may be light on another planet light-years away. Without a doubt, we're discussing the James Webb Space Telescope. The James Webb Space Telescope is the creation born out of the traditions of human endeavors into space to address some ever-present questions. Are we alone? Who's out there? Where do we start and where do we end? This infrared space science contraption has already begun addressing these inquiries. At first, you might find yourself asking, what is Proxima B? Proxima Centauri B, or simply Proxima B, is sometimes referred to as Alpha Centauri. It is a super-Earth exoplanet and orbits an M-type star. Super-Earths might confuse you, but don't worry. This text will settle all your burning questions. Super-Earths are a class of planets that are more immense than Earth but lighter than ice giants like Neptune and Uranus. They are unique and can be made of gas, rock, or even a mix of both. Their sizes can range from twice the size of Earth to several times its mass. As for Proxima B, it is a super-Earth and an exoplanet, meaning that it orbits outside the solar system. The essential possible evidence of an exoplanet was found as early as 1917, though it sparked little interest. However, confirmation came in 1992 with the first affirmed discovery, which left experts astounded. Another exoplanet, first recognized in 1988, was confirmed in 2003. As of April 1, 2024, there are 5,653 confirmed exoplanets in 4,161 planetary systems. Of these, 896 systems have more than one planet. These well-known discoveries are surrounding an M-type star. To comprehend an M-type star, you need to understand the red dwarf. A red dwarf is the smallest type of star in the main sequence. In the interconnecting region of the Sun, red dwarfs are by far the most common type of star found in the Milky Way. They have phenomenally low luminosity, and since brightness is one of our main tools for planet discovery, red dwarfs are hard to see. These dim stars have variable definitions and names depending on their temperatures and sizes. For example, M dwarfs or M-type main sequence stars yield a maximum temperature of around 3000 K, thus earning their name. As for Proxima B, its mass is known to be almost identical to 1.07 Earth's. Interestingly, it only requires 11.2 days to complete one orbit of its star, compared to our 365.25 days. You can measure the size of the star Proxima B is orbiting by considering the entire electromagnetic spectrum. The star has a total luminosity of as little as around 1.6% of that of the Sun. In the visible light range, its brightness appears to diminish further, shining only 5 to 6% of the Sun's brightness and emitting much less light energy compared to the Sun. More than 85% of its emitted energy is infrared radiation. Proxima B orbits its star at a distance of about 0.045 to 0.056 Australian dollars. Its discovery was reported back in 2016. You might ask, why is Proxima B, among millions of stars, planets, and galaxies, of such interest? Well, there are several reasons that contribute to astronomers' fascination. Proxima B is the closest known star to our Sun. By definition, although 4.2 light-years is a large number to us Earthlings, in the grand scheme of the universe, it is a mere blip. So why is Proxima B, our nearest known star, high on the priority list? Right now, it is part of the triple star system called Alpha Centauri. Despite Proxima's low brightness, the system itself appears as one of the brightest celestial bodies in the night sky, just behind two others called Sirius and Canopus. However, the most captivating thing about Proxima Centauri B is that it could genuinely be habitable, as it falls within the habitable zone. The possibilities surrounding the star are endless. Space specialists have taken up the task of exploring the depths and limits of the star's potential habitability. That's where the James Webb Space Telescope comes in. The four main objectives of the JWST are to search for light from the first stars and galaxies that formed in the universe after the Big Bang, to study the universe's evolution and development, to understand star and planet formation, and to focus on planetary systems and the origins of life. As the JWST continues its assessment of the said exoplanet, we move closer to the zenith of these missions, from searching for exoplanets to searching for extraterrestrial life. What exactly is said to be one of its goals? Considering that humans have always been a curious species, exploring and examining everything that moves and doesn't move, it makes sense that a mission like this has emerged on such a massive scale. Imagine that the universe is a vast, intricate project, and we are tasked with being the ones on watch for signals. More specifically, electromagnetic murmurs from human-like advancements beyond anything we could ever imagine.